Hi, everybody. So in this video, we're going to be looking a little more specifically at how you can tell whether two quantities are proportional, talk a little bit about why you should care, and look a bit at how you do some of the calculations that you're often asked to do with proportional quantities. As with the last example, the last video, you have a form, and I will be asking you to answer a number of questions on that form. So that's a basic question. So we have two quantities, Q and R. So this could be population and number of votes in the House of seats in the House of Representatives. It could be population and number of electoral college votes, or any number of other things. And how do you know if they're proportional? They're proportional if you can describe the equation just using a rate and nothing more. There's one representative to every 710,000 people, or 710,000 people per representative. You might be paid $12.50 an hour. You might drive 55 miles per hour. In each one of these, the relationship is proportional. The amount you're paid and the number of hours you work, the distance you drive, and the amount of time you spend driving. Another way to say this would be to say that the equation looks like Q is equal to some constant K times R for some fixed number K, which we call the constant of proportionality. For example, the number of representatives is 1 over 710,000 times the population. You also could describe that as saying the population is 710,000 times the number of reps. Those are both just fine. That is a proportional relationship, whereas the number of electoral college votes would be 1 over 710,000 times the population plus 2. And that plus 2 was enough to make it no longer a proportional relationship. So it has to be this very, very simple shape. For another example, the amount you're paid might be $12.50 times the number of hours that you work, where the constant of proportionality would be $12.50. Very simple relationship. These first two ways of telling whether things are proportional can feel a little bit abstract, and sometimes you might get a little bit confused and you're not sure. So it's helpful to have a very concrete way to check. And we can use what we looked at when we were talking about Tennessee and Illinois and Florida. That is, if you double or triple or have one quantity, you need to do the same to the other one for the two things that are proportional. If you multiply Q by a number, you need to multiply R by exactly the same number. Twice as many people, twice as many seats in the House of Representatives. Work twice as long, make twice as much money. Drive for half the time, go half the distance. Those are proportional, but remember, Florida had 3 times the population of Tennessee and did not have 3 times the electoral college votes, so those were not proportional. And this last version can be really useful if you're a little confused. It gives you something very concrete to check. So why don't you try this? I have 4 questions here. You'll see the first 3 are actually straight off the homework. So for each one of these, answer whether you think they're proportional and give me your thoughts on the form. Okay, here are my answers. Hopefully you've done them already. S is equal to 0.35 G minus 1.2. These aren't proportional. You can tell this just by looking at the equation that minus 1.2 screws you up, or you can try the doubling trick. Try plugging in G is equal to 10, and you get S is 2.3. But if you double G to 20 and plug that in, you would get S of 5.8. And 5.8 is not what you get by doubling 2.3. So they are not proportional. About 3Q is equal to 7G. That's a funny shape for an equation, but you could rewrite it as Q is equal to 7/3 times G. I divided both sides by 3. So that is a proportional relationship with constant of proportionality 7/3. There are 7/3 of a Q to every G, or 7/3 Qs per G. And the last one, B is equal to 7 divided by M. Those are not proportional. Again, the simplest way to see that is plugging in. If M is 1, you get B is equal to 7. But if you double M to 2, B becomes 3.5. It certainly does not double to 14. So those are not proportional relationships. And your score on a test versus the amount of time you spend studying, do you think you can double your score on the test by studying for twice as long? I certainly don't. So I would not expect those to be proportional. Can you multiply score by 10 if you study 10 times as much. Certainly not necessarily. That's what it means for things to be proportional. Why do we care? Often we care because strange things happen when they're not proportional. Two things being proportional pretty much line up with our sense of fairness. Twice as many people, twice as many resources, twice as many votes. If things stay in proportion, that's pretty straightforward. It lines up with what we expect. When they are out of proportion, that's often where something as interesting is going on, and we really want to understand what's happening. And that's what Buffett was talking about in that op-ed, that if you double the carbon dioxide, you might do far worse than doubling the number of problems. It can scale up explosively. Proportional also lines up with what we're thinking about when we're talking about making things larger or making things smaller. If you want to scale something up, you have to keep all of its ratios or sizes in proportion for it to look or seem the same. If you're baking and you want to make twice as many cookies, you have to use twice as much sugar and twice as much chocolate and twice as many eggs, or else they're not going to taste right. If you want to make a scale model of something that is a quarter the size, you need to make it a quarter as tall and a quarter as wide. If it's a model doll, you need to make its arms 1/4 the length. You need to multiply all of its lengths by the same thing for it to stay proportional and look right, only smaller. So let's think about that. Think about babies. Do you think babies' bodies are in proportion to adults' bodies? If you took a baby and you scaled them up to adult size, would they look like adults? Give me your thoughts quickly on the form. I love these pictures. If a baby tries to put their hands over their head, their hands don't even touch. Whereas an adult, you can certainly put your hands over your head and there's lots of room. Babies' bodies are not proportional to adults' bodies. Babies have incredibly large heads relative to their own body size. Their heads are smaller than adults' heads, but the ratio between their heads and their arms is very different than the corresponding ratio for adults. So scaling is really the last thing we want to talk about when we're looking at proportions. So I just wanted to look fairly quickly at two approaches you can take to solve a scaling problem. So let's say I was buying cherries and I spent $3.50 on a 10-ounce bag of cherries. How much would a 24-ounce bag cost? Like you do the calculation here and give me your answer on the form. And remember, I'm confused is always a fair answer. Okay, there are two different approaches you could take to answering this. One is the unit rate approach. Figure out what the constant of proportionality is. What is the cost per ounce of my cherry? And just saying that tells me the equation. I want to know the cost per ounce. So I want the cost divided by the weight, the number of ounces. In this case, that would be 350 divided by 10, or 0.35. My cherries cost 35 cents per ounce. So to buy 24 ounces, I would take that 35 cents per ounce and multiply by 24 to give me $8.40. So I calculated that constant of proportionality in order to solve the problem. There's another approach I could have taken, and that would be to use that idea that if things are proportional, if you double one, the other one doubles. So I say, well, how many more cherries are there in that 24-ounce bag? There are, if I take my 24-ounce bag and divide it by 10 ounces, there are 2.4 times as many cherries in the 24-ounce bag as in the 10-ounce bag. So I must have to pay 2.4 times as much. So if I take the cost of the 10-ounce bag and I multiply this by 2.4, I would get the cost of the 24-ounce bag, $8.40. And notice I never figured out the cost per ounce. I did a very different calculation here, but I got the answer. It's the same answer, which is good because there's only one right answer. There's just two different approaches to getting it. So I want you to go think about the calculation you did and think which of these calculations, the scale factor approach, what do I need to multiply the bag size by, or the unit rate approach, what was the cost per ounce? Which of these is closer to the calculation you did, or is your calculation really different from both of these approaches? So think about that and give me your answer on the form. We're going to be, among other things, doing some more talking about scaling things up in class. Great. Thank you. This is the end of this video. I look forward to reading your thoughts on the form. And as always, please let me know if you have any questions on this material, or if you have any feedback for me on how these sorts of videos are working for you and anything which would make it work more smoothly. I look forward to seeing you soon. And I should say, questions that come up on the forums, I will generally be answering in class. If you have a question that you want me to answer individually or that's urgent, please email me, because that's how I would get those.